Engineering Renaissance, the calling of a new engineer. Hi, my name is Kai Zuan. I'm the Renaissance Engineering instructor and curriculum designer at Lausanne School of Engineering at York University. For the past 14 years, I've been involved in engineering education, first as a student, then a researcher, then an educator. This 14-year journey has took me to 4 countries, 6 academic institutions, and across a wide variety of disciplines, both technical and humanistic. As an educator, I've been deeply interested in the question of how can engineering education improve to better serve our students and our society. Since joining Lausanne, I've been working on the vision and concept of Renaissance engineering. Renaissance engineering envisions a new engineer beyond the technical expert. This new engineer is an innovator of disruptive solutions, a collaborator in multidisciplinary teams, a system thinker cognizant of the bigger picture, and a leader willing to challenge the status quo. Renaissance engineering proposes that in order to train the new engineer, a new engineering education is needed. Education that combines technical training with broad perspective, humanistic skills, an awareness of self and the world around, and the ability to contribute positively to society. My task is to explore strategies for implementing this vision of Renaissance engineering. In order to do so, I've interviewed students, faculty, staff, collaborators, and stakeholders. I've investigated a number of progressive institutions and innovative approaches, combining this with my own perspectives and experiences. Here, I've gathered the insights from this investigation into a video series called Engineering Renaissance. In this video series, I'm hoping to explore and address the question of why do we need Renaissance engineering, what is Renaissance engineering, and how do we do Renaissance engineering. I hope this video series to be informative, inspiring, and serve as a catalyst for change. So, without further ado, Engineering Renaissance. Part 1, Calling of a New Engineer. Before I start, I'd like to give the definition of a Renaissance engineer. A Renaissance engineer is an engineer who complements his or her technical expertise with humanistic skills and systems capacities in order to contribute broadly, meaningfully, and positively to society. Please do not think of this definition as a very strict definition. Instead, think of it as a scaffold for learning and growth. The word Renaissance comes from Old French, meaning rebirth. The term Renaissance engineering implies a need for a fundamental transformation or a rebirthing of engineering education. In this video, we'll explore the shortcomings of the traditional engineering education and relate the solutions to these shortcomings to the concept of Renaissance engineering. Since the inception of engineering profession, engineering has served as the connector or bridge between technology and society. In this sense, engineering education has the purpose of maintaining the strength and vitality of this connection. However, it seems that today's engineering education was designed and optimized for the world of yesterday. As a result, it has led to a disconnect between technology and today's society. The 3 specific disconnects within engineering education are the narrowing of skills and perspectives, the lacking of systems capacities, and the neglect of intrinsic motivation. When this connection is healthy, engineers are able to have broad societal impacts. For example, great engineers of past and present weren't just technical experts, they were innovators and influential in business, culture, politics, and other spheres of society. An example of a great engineer is Henry Ford, who was the creator of the first affordable automobile. More importantly, his invention of the assembly line fundamentally transformed modern economy. A very different and more modern example is James Dyson of the Dyson Company, famous for their vacuums. Dyson was the engineer behind the cyclonal method of vacuuming, but also the designer that created the attractive exterior casings used in Dyson vacuums. A third example is a Canadian engineer, Jeffrey Skrull. Jeffrey was employee number one and former president at eBay, and also the producer of Oscar-winning film The Inconvenient Truth. Each of these great engineers have made broad and impactful contributions to society, but in very different ways. What do they have in common? What made them great engineers? One argument is that they're all well-rounded individuals with broad perspectives and capable of blending the technical and the humanistic. This is not what most people think of when they think about engineers. The cultural perception of engineers are individuals that are technically focused with narrow perspectives. The caricature of engineers reflecting this cultural perception is the nerd that only knows math, the drone that just does what he's told to do, and the otherworldly who's completely out of touch with reality and society. Unfortunately, this cultural perception is not wholly inaccurate. Over the past few decades, engineer education has gradually moved away from humanistic in favor of the technical, creating a skewed engineer education leading to a narrowing of societal impacts. Today's engineers are mostly technical experts. Their influence in innovation, business, culture, and politics have diminished. What we need is a broadening of engineer education and a rebalancing of technical and humanistic education. The second disconnect within engineer education is the lacking of systems capacities. And this has to do with the evolution of complexity in technology and society. To understand this, we'll make use of the four industrial revolutions framing proposed by the World Economic Forum. During the first industrial revolution, characterized by mechanization and the use of steam power, as well as the second industrial revolution, characterized by mass production and the use of electricity, most problems encountered by engineering are simple or complicated problems. These problems are well-defined, narrow in scope, and technical in nature. Simple problems can be solved procedurally, whereas complicated problems can be solved using the combination of coordination and specialization. For example, solving a math problem is a simple problem, whereas the building of a bridge or designing of a fast car are complicated problems. Since the beginning of the third industrial revolution, characterized by electronics, IT, and automation, and with the onset of fourth industrial revolution involving cyber-physical systems, nanotechnology, and biotechnology, a third class of problems, the wicked mess problems, have arisen. Wicked mess are problems that are ill-defined, involving conflicting interests and shifting constraints. These problems are broad in scope and multidisciplinary in nature, involving both social and technical aspects. For example, the launching of a social app and the designing of sustainable cities are both wicked mess problems. Today's engineering education, overly focused on technical specialization, is optimized for the solving of simple and complicated problems. This approach is insufficient for working with wicked mess. To work with wicked mess, engineers need to have systems capacities. Systems capacities such as the ability to see the larger system, to reflect deeply and evolve when necessary, and to collaborate and co-create across disciplines. The development of these systems capacities must become an integral part of engineering education. A third disconnect in engineering education today is the neglecting of intrinsic motivation. In the past, majority of people were happy to fit inside predefined boxes and become so-called cogs in the machine, as long as they were paid at the end of the day so that they can go buy a house, buy a TV, and go on vacation once in a while. The house, the TV, and the vacations are motivations called extrinsic motivation. This system of motivation worked well during the first and second industrial revolution. As such, our education has evolved around extrinsic motivations such as grades and the promise of good careers. Not to say that the house, the TV, and the vacations are bad, but speaking as a millennial, this is not enough for us. We want freedom, autonomy, and choice, and we don't want to fit into boxes. The millennial generation wants to be known for our individuality and diversity. We want to be celebrated for our unique combinations of passion, aptitude, creativity, and wisdom. Most importantly, we want to live life with a purpose and to make a difference in the world. For the millennials that chose the path of engineering, it can be more than a career, it can be a calling. More than just good grades or a good career, the millennial generation demands a meaningful and intrinsically motivated education. Thus far, we've discussed the three disconnects within engineering education: the narrowing of skills and perspectives, the lacking of systems capacities, and the neglecting of intrinsic motivation. We've also touched upon the three solutions: the broadening of skills and perspectives, the development of systems capacities, the making of engineering education meaningful. These three solutions form the basis for a Renaissance engineering education, an education that combines technical training with broader perspectives, humanistic skills, and systems capacities. This education is designed to prepare students for contributing broadly, meaningfully, and positively to society. In this video, we've covered why do we need Renaissance engineering and a bit of what is Renaissance engineering. In the next video, we'll focus on a detailed discussion of what is Renaissance engineering and how do we do Renaissance engineering. For the students of ENG 1101, as well as anyone else watching this video that's interested, I prepared a number of discussion questions. First, are the great engineers mentioned in this video, Henry Ford, James Dyson, Jeffrey School, Renaissance engineers? We can use the definition given in the beginning. A Renaissance engineer is an engineer who complements his or her technical expertise with humanistic skills and systems capacities in order to contribute broadly, meaningfully, and positively to society. Question 2. What can you do to become a Renaissance engineer? Again, using the same definition. Question 3. How does ENG 1101 materials and materials of any similar courses address the three disconnects between technology and society: the narrowing of skills and perspectives, the lacking of systems capacities, and the neglecting of intrinsic motivation? Thank you, and I hope to see you for the next video.